Gas fitter exam cram session, video 24. Okay, we touched upon the volume of gas to be provided is determined by the appliance served. When I spoke about the flexible connectors to a stove, that the longer you go, the less gas is being delivered to the unit. So, in certain situations, you might want to check by the nameplate on the unit, the manufacturer's plate on the unit, giving you the stats of the unit, how much gas that unit needs. Or, you could check with the manufacturer's information that comes with the unit. That's going to determine what size pipe you're going to need, what demand you're going to need. It's almost the same as, let's say, what size waistline are we running to the fixtures? Well, what's the fixture unit value? What's the total load that any one section is going to take? That determines what size. Same thing. What is going to be the demand of the gas? So if we're running cooking gas to an apartment building, if each unit has one stove, and each stove, we're going to say, has a certain requirement. Let's say each stove needs, for the sake of argument, each stove needs a cubic foot of gas to work, right? And we have 10 units, 10 stoves, so that's 10 cubic feet of gas. We use that number to determine now the size of the piping according to the utilities, tables, and charts, etc. But here, the volume of gas to be provided must be determined directly from the input rating of the appliance served. So, the appliance itself tells you what it needs. Figure out the total need of all the appliances, even if it's just one or all of them, and that's how much gas we need. The appliance tells you, input rating. Question 4. Page 40, question 4. Individual outlets to gas ranges shall not be less than 3/4 of an inch, or 0.75. On your calculator, if you're not sure, 3/4 is 3 divided by 4. So, in your calculator, 3 divided by 4 gives you 0.75. Or, since we're not allowed calculators on the test, and I know this is a very simple example, but this method you can use for some things that don't seem that simple. 0.75, what is that in money? 0.75 is 75 cents. 75 cents is what? 3/4. I got 3/4 in my pocket. I don't have $1. I have 3/4 of a dollar. Okay. When we were talking about the test T, that a test T or drip leg has to be downstream of a lockable supply valve, we mentioned that the test T, when we mentioned the drip leg, two reasons why we don't see it. The most important reason is to eliminate unwanted connections. Another reason is, we have dry gas, so we don't need it anymore. The test T. Test T is for testing. So usually it sits there when there's no test. It's plugged. The outlet of the T is plugged. That size is 1/2 inch. Since you have to have at least a 3/4 inch line to a range, that 1/2 inch line discourages an unwanted connection to a stove, since the stove's just not going to work. 1/2 inch is just not going to supply the amount of gas you need for that. Question 5. Except for commercial, industrial, and other large volume use, no gas distribution piping containing gas at a pressure of more than 1/2 psi shall be run within the building. I think this was almost from day one I mentioned that. The blanket statement is no more than 1/2 psi. That's what we're running. Anything else is an exception. We'll deal with it. You can have pressures higher than that in building piping, but that's an exception. And in this case, the exception is for commercial, industrial, and other large volume use. So, maybe a residential building is not commercial, industrial, but if it's in an apartment complex, if this is a huge high-rise, the boilers are going to be pretty huge. They're going to require a great amount of gas, large volume use. That line may be maybe over half a psi. It'll be in the half to 5 psi range. Okay? Maybe, possible. Question 6. Of the following materials, which one is acceptable in a gas piping system? Carbon steel or wrought iron? Carbon steel is steel. Other steel is stainless steel. Wrought iron, as I said, was the precursor to steel. It was used when we were hand threading. When we came out with power threaders, wrought iron just, walked off into the distance. Okay? It's all steel now. But wrought iron remains in the text of the code. Probably never see it, but it's an acceptable material. For the sake of review, let's go over the other ones to see what is not acceptable material. Cast iron pipe, too brittle. Copper or brass pipe, too soft. Aluminum pipe, even softer than that, no good. Question 7. Plastic may only be used for gas piping outdoors if it's below the ground. So we shouldn't be seeing it. Okay? The only time you're going to see plastic piping is now with those third-party contractors. You're going to see sections of the street, big plastic pipes and fittings laying there. When they're not working, it just lays there. They're not worried about anybody walking off with that. And during the day, when they are working on it, the big trucks, the guillotine cutter, the fuse welder, they heat fuse the piping together, they're laying the pipe in there, etc., etc. The yellow paint, the yellow spray paint on the street marking the mains, and if you're lucky, you'll see 15 psi. Sometimes they'll even show the sizes, 6-inch main, and then service here, 2-inch service, whatever. Okay, but plastic. And this is PE piping, not yellow piping is plastic. It's polyethylene. It's not PVC like you would use in waste. It's not PEX like you're going to use in a radiant floor. This is PE, polyethylene. Okay. Question 8. For steel gas piping, threaded fittings larger than how many inches are not permitted? We're not given a specific pressure, so we're going to go with the largest possible that we could ever use. Here they're asking a threaded fitting larger than, so we know the largest possible fitting we can ever use is a 4-inch fitting. Anything larger than that is not allowed. The correct answer is 4. Okay? This is not phrased exactly as in the code, so this language here, if you don't take your time and always remember and reinforce, go through it if you have to. You have all the time in the world. You got to establish exactly what you remembered is absolutely correct. Then work from there. Here, larger than. Well, what is the largest? 4. Anything larger than is not permitted. So 4 is still the correct answer. Okay? Because you could have this question phrased as, for steel gas piping, threaded fittings shall not be used for sizes, blah, 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 and over. Okay? If it was phrased that way, D, 5 inches would be the correct answer. Okay? Threaded fittings shall not be used for 5 inches and over. Or threaded fittings, threaded fittings take larger than out, 5 inches and over are not permitted. You could rephrase it that way, and that would be the answer. But for 8 right now, the way it's phrased, 4 inches is the answer. Question 9. Used pipe, fittings, valve. Already I'm thinking like they said the word used. I'm thinking, no, not allowed, period. But let's finish reading the question, right? Used pipe, fittings, valves, and other materials must not be used in the gas piping system except where they are free of. That sounds like you're trying to trick me. D, you can't fool me. Material cannot be used under any condition. Look at the wording of the question, trying to lead you like a less than ethical cop, questioning you because it's a hot case and they need to pin it on someone, and you're just as good as anybody. Look how leading that question is. Used pipe, fittings, valves, and other materials must not be used in the gas piping system except when they are free of. You almost make it sound like that sentence actually exists in the code. And we know it doesn't, except where they are. No, this is it's like, this is the lawyer trying to entrap me on the witness stand. This is the cop trying to get a false confession out of me. I mean, yeah, you gotta watch for that. That question sounded pretty official. That question's a fucking scumbag. That ain't your friend, Yeah, you're in the interview room, and then the cop all of a sudden's your friend. It's like, I never met you before in my life. It's like, you're looking out for me. You're my friend. It's like, so what are we going? We're going to each other's barbecues next week. We're going to start, looking at each other's kids' pictures and shit. I mean, come on. Watch that question. That question does not have your best interest at heart. Yeah. You know what? You want that one phone call now. Yeah. Lawyer. Yeah. I see a question like that. Lawyer. Okay. Page 41. Question 10. Gas piping must not be installed in or through B. A clothes chute. A clothes chute. Okay? Now, when we go into the code, there's only so much you can put in these questions. Okay? There are a lot of places you cannot run gas piping. Okay? And there are places where, like, you can run it, but not if it's this or that. Okay? You can run gas piping in a plenum, because a plenum can be so many things. Because I know we just got done in the previous test where we're not going to run it through a return air plenum. We're not going to run it in a furnace plenum. But there are other plenums. Okay? And a plenum can take the shape of ductwork, actual large sections of ductwork. But plenums can also simply be the space in between a drop ceiling and the structural ceiling. Plenums, we have a return air plenum, but there's also a supply air plenum. There's also an exhaust air plenum. So, plenum by itself is not a no-no. Okay, so, attic. We can run gas piping in an attic. We just can't put a gas-fired water heater in the attic. But we can run the piping in the attic. Let's say we can run the piping in the attic and then bring it down. If you can run underneath the floor and bring it up, you will also run overhead and bring it down. We can run gas piping in an enclosed space. Although all enclosed spaces are not the same, and we're going to start seeing where in certain situations there's a lot of things you got to do if you're going to run the piping in that particular enclosed space. But an enclosed space per se, no. The one you definitely cannot run it in or through is the clothes chute. Okay? No clothes chute. Alright, this is when you can have a clothes chute in a house. That would be kind of nice, So all the laundry goes right to the laundry room in your basement from the bathroom. Just be like a little door and you send it in. That's nice. But more often clothes chute you're going to see in hotels because that makes life easier. But no piping in that. Question 11. Piping systems may be purged indoors with fuel gas if the design operating pressure is 2 psi or less. Here's another one. So, not that I'm holding information back from you, okay? You're going to get to see everything, but in order to pick up huge bodies of information, you got to start with the most important, and you got to build a foundation. So, I remember saying in the beginning, and you might remember me saying this, I believe out of all the four most important tables we need to know, the tables I put in the back because that's how important I thought they were. I did say that the table I thought had the most information was the threading. Okay, so that takes a while to learn. It's a lot of information, more than the others. And then I said the most difficult table was the purging one. Now, for what we've done with the purging, you might look and say, well, I don't think it's that difficult. And it's like, no, if we left it at this, no, it's not that difficult. But this was the basics. This was the basic, the foundation. This is what you really needed to get down first. Okay? Before we start going into why I believe it's the most difficult, because there's a lot of back and forth. There's a lot of finer meanings to this. Now we're going to start going into it, okay? And if I start talking to you about pressures of gas, you had enough pressures of gas to remember with the test pressures and other pressures. Notice that when I make this table in the back for the testing pressures, these are the basic pressures, but we still come up with exceptions in that for all the gas testing pressures, in test 3 we learned that, well, if we're running piping in a corridor under the specific conditions that the code gives us for that, the test pressures for that piping alone now is 10 psi for 30. I put that in the beginning. That's just so much more information. But when did I give it to you? After you got the main gist of the table under your belt and could handle that, okay? You know, you don't eat the entire meal in one shot. You have courses. You start off with this and that and then work your way up to it, and then after the main meal, maybe you might have a couple of little extras. Can't have the whole meal in one shot. You can't have the aperitif and everything from that up to the dessert in one shot, each at a time. And you don't start off with the gigantic steak. Start off with an appetizer, or maybe just a drink first, correct? While you wait for your table. So, piping systems may be purged indoors with fuel gas if the designed operating pressure is 2 psi or less. That 2 doesn't match anything we've dealt with. So that 2 is a number we're just going to have to learn. Okay? 2. Just like we kind of learned the corridor piping test pressure is going to be 10 psi for 30 minutes, separate from the rest of the table because it's unusual, it's an exception. It's a number. It's a relationship that doesn't really fit with the others that much, that well, I believe. So we learned that one by itself. So same thing here, okay? Purging, and this is just one of the many finer points of purging that now we're going to start working on, because purging by itself, I believe, is the most difficult out of all of them. Exactly what it is, when you can do it, the many different ways you can do it, how you're gonna do it, all the numbers involved in doing it, and the quality of the numbers. What's the quality of the numbers? We learned the numbers, and then we learned, is it at that number, or over that number, under that number and over, or that number and under, etc., etc. Okay. Purging. If indoors, you might want to make a flashcard for this one, right? If indoors, okay. And what's the quality of this number? 2 is 2 psi or less. So 2 or less, right? 2 psi or less. 2 or less, you can purge with what? Fuel gas. Because we mentioned there's two times you might want to purge. You might want to purge when you first cut into the system and you're going to be working on the system. You might want to get rid of the excess gas in there. Then the other time you're going to purge is the system's already connected, pass inspection. You want to start firing up. You want to start feeding the units with gas. You can put fuel gas in there. You don't have to purge with inert gas first and then send the fuel gas, because that's another fine point. I'm going to bring it up. I'm going to touch on it now, and then we'll reinforce it, because when we start doing purging from the code's point of view, when we go through the code, that's when you start seeing all the nuances, and then all this stuff will work itself in. Depending on the kind of system you're working with, you might have to, when you're turning on, you might have to first purge with inert gas. Then you can send the fuel gas in. But for now, we're going to stick with this question. Piping systems may be purged indoors. Blanket statement is, if we're going to purge, we're going to do it with, we're going to have the purging, whatever gases we're purging with, they get exhausted outdoors. Our purging port opening is outdoors. But you don't need to do that. You can purge indoors with fuel gas if the design operating pressure is 2 psi or less. Okay? You can purge indoors with fuel gas, 2 psi or less. All those words now, this is the first time we're seeing it. Right now, we're gonna, right now is the shock. Once the shock is over, we can start streamlining this, making our memory, what we say, our a more efficient memory. We're going to start getting rid of the words, okay? But that's it, 2 psi or less. Most important walk away is, what's the main number? And what are we dealing with in general? A lot of words. We'll shave that. Okay. Question 12. Portions of gas piping systems installed in concealed locations. What's a concealed location? A non-accessible location. Accessible location. You can see it. You can open a door easily. There's a panel, Concealed location. You got to break out the hammer or the sawzall now to get to it. Okay? Or chipping hammer even. Locations must not have unions. Okay? No unions. And we said unions are kind of easy. There's really only one place we're allowed the union, and that's after the appliance shutoff valve. We're not allowed a union after the lockable supply valve. After the lockable supply valve, we were allowed the test T, the drip leg. Didn't mention anything about a union. Okay? What would we use in that case? A left-right coupling. If we have to have some, if we have piping coming from two directions, the threads, you're never going to be able to make that up. The left-right coupling, you can make that up. Left-right nipple and coupling, but no union. Union is strictly for the appliance, and it's got to come downstream of the appliance shutoff valve. Keep trying to use their word and call everything officially what they want it to be called. So, the appliance shutoff valve is not the same thing as the lockable supply valve that you might see at the base of the riser. Okay, but no unions in concealed locations. Unions can loosen up due to vibration. You got a leak, it's in a concealed location. You'll never know, you'll never find out until boom. Okay? 11. Branches shall be taken off a gas riser with not less than a 2 elbow swing. Okay? So, 2 psi or less. What a coincidence. Questions grouped together. we can actually put numbers together. Right? What a coincidence. How fortuitous that this question shows up for us, right? 2 elbow swing. Now, we don't need to make a big separate deal out of, okay, that branches shall be taken off a gas riser, and then branches shall be taken off a main, a horizontal main. If you remember when I was drawing the picture for the test T and drip leg downstream of a lockable supply valve, I had my little horizontal main and I already put 2 elbows on there. I automatically 2 elbow swing off that main. 2 elbow swing. We're just going to take it for granted that, you know what, if we're just taking a branch off the horizontal main, if we're taking a branch off the riser, we're going to put a 2 elbow swing. Now, one of the finer points of the 2 elbow swing off the riser. We count 2 elbows after it's outside the wall. Okay? If you're running an exposed riser, your 2 elbows are your 2 elbows because it's right there. It's exposed. 2 elbows. If you're in the wall, okay, and I know this would make life sweeter, I always feel that in a gas system, if you can do a job with 1 elbow instead of 2, then hey, you know, if you can do a job with 1 fitting less, and you know, you've just saved yourself 2 joints. I see every joint as a potential leak. The less potential leaks, the less chance of having a leak. So I always say, you know, the most efficient route, you know, the straightest, the shortest distance between 2 points is a straight line. Well, try and find the straightest line possible, given the piping and the fittings and everything you have. I always go for the least amount of joints possible. But when it comes to the 2 elbow swing off the riser, if I'm in the wall, and to get out of the wall so that I have my appliance shutoff valve in the same room as the appliance, accessible, and just to get out of the wall, I went over and up and out. Those are 2 elbows. Did I not take my swing off? Did I not take a 2 elbow swing off the riser? I feel I'm done. Unfortunately, I'm not. I wish I was done. I'm not. It's going to stick out of the wall. There's the valve. My argument is says, well, I've satisfied the code. I have not satisfied the code. No matter what you do inside the wall, the minute the pipe comes out of the wall, there's where your 2 elbows start. So guess what? As much as I don't like to put any more joints than necessary, I do have to put 2 more elbows there. Okay? They gotta be outside the wall. Okay? And then I put my appliance shutoff valve, and then I hook up my stove. Okay? So it's gotta be outside the wall, this 2 elbow swing, regardless of what you did in the wall. Okay? So keep that in mind. Question 14. Gas piping entering through a foundation wall underground shall be protected by encasing it in a protective sleeve. So we're generally talking about the service. Okay, there could be other situations, but most often than not, it's the service. From the main, in the street, underground, to the basement or cellar, it's going through the wall, it's finally going to stick out of the wall, house control valve within 2 feet of where it entered. That piping going through the wall, like any piping you would want to put through the wall, is got to have some kind of protection. In this case, we're going to encase it in a protective sleeve. Okay? So, gas piping entering through a foundation wall underground shall be protected by encasing it in a protective sleeve. Question 15. Concealed gas piping shall not be in solid partitions and solid walls. That's the blanket statement, unless